Welcome again. So this is part 1 of Introduction to the Command Line. The learning objectives: to give you a background on Unix and the fundamentals of the operating system, to introduce you to the Linux shell, to give you a breakdown of the command usage and some of the most important commands, to give you an intro to the command line editors, to give you an intro to a complete cluster and the resource manager, to give you an intro to workflow tools, to give you an intro to software containerization. And the learning outcomes is to understand the background of the Unix environment, to understand the need for using the command line for scientific computing, and to be comfortable with navigating the environment, doing file and directory manipulations, and working with pipes and filters. To understand the cluster environment basics and be able to submit an interactive job, to be familiar with workflow tools, and to be familiar with software containerization. So what is Unix? It's a stable, multi-user, multitasking operating system for servers, desktops, laptops, and it exists in many variants. Unix systems are characterized by modular design, so a set of simple tools that each perform a limited, well-defined function, with a unified file system as the main means of communication, and a shell scripting and command line language that combine the tools to perform a complete workflow. There's many Unix flavors: Sun Solaris, Mac OS X, GNU Linux, UnixWare, FreeBSD, OpenBSD, IBM iX, and HP Unix. The difference is, in terms of GNU Linux distribution, is in the package managers, the directory structures, the file naming, and the suitability. So if they are more designed for servers or desktops. And there are many distributions like Debian, Ubuntu, Fedora, OpenSUSE, SUSE Linux Enterprise, Scientific Linux, Red Hat, and CentOS. This is a timeline of the development of Unix. So in early 1970s, in the Bell Labs, Ken Thompson and Dennis Ritchie developed Unix. And that branched into two different branches that was more commercial based and then more academic based. Mac OS X developed from Next Step, and the current GNU Linux that you have today was a collaborative project between Richard Stallman and Linus Torvalds. Richard Stallman developed the GNU software, and Linus Torvalds developed the kernel. So all in all, the fundamentals of the Unix system are the same. They have a kernel which allocates time and memory to the programs, handles storage and communication. A shell that is the interface between the user and kernel, and it has a command line interpreter. And the terminal or the console, which is the interface to the shell. It complies to POSIX standards, which stands for Portable Operating System Interface. And there's a username, password, home directory, group permissions, and a default shell. Each process has a unique identifier, and there's a unique directory structure and files for files and directories on the system. Here is just a breakdown of the directory structure that you would find on the root system of a Ubuntu file, a Ubuntu machine. So you have the bin that contains the user bin binaries, boot, the bootloader and kernel image, dev, the device files, etc, the configuration files, home for user home directories, lib for system libraries, lost and found for files that can be restored, media for removable devices, mount for mount directory, opt for additional software, proc for process information, root for super user home directory, sbin for system binaries, srv for directories of services, device information goes into sys, temporary files goes into temp, user programs goes into user, and variable files goes into var. Permissions. So in a multi-user system, access and access restrictions are a key. Typically, you are the owner of every file directory you create or bring into a system, but whatever other files and directories you read, write, or execute will depend on how the system is set up. In this image is a screenshot of a directory and the directories that are within that directory. So the information that is presented here on the left, you will have the permissions, the user and group of that specific folder, the size of the folder, the time of last change to the folder, and then the folder name or file name. Now, the permissions are broken down on user, group, and owner, and for each user or group or owner, it's broken down even further to give it read, write, or executable rights. So, for example, you would see that in this example where you have the Baylor directory, it belongs to Garrett and the H3A group, but it's only readable, writable, executable, and readable, writable, executable for the group, but no other people can access it. So it's private. Whereas in the GIB for the genome on the bottle, which is a public data set, you would see it's readable and writable to user Garrett, but for all other users it's also readable and executable. It means that they can traverse into the directory and actually view the files. The shell is a command line interface to the operating system for browsing file system and issuing commands. All in all, it's a programming language. A shell script provides a way to automate repetitive tasks, and you've got different shells with different features. The command anatomy is basically you have a command and some options or flags, and then input and output. Depending on the command, the input can be read from standard in stream, the output from a command or from a file, and depending on the command output, it can be sent to a standard out stream to the input of the next command or to a file. Error messages are normally sent to standard error stream, and to get more detailed information about the command flag and usage, make use of the man pages. For example, man.ls. Now, standard in is the input that you can type in from the shell, and standard output is normally output that's being generated from a command. Standard error is also output that's generated from a command, but it's kind of an error message. So it's a stream. It's different to the standard out, and it needs to be cached differently also. Here is a list of important commands. So we have got the ls to list files, cd to change directory, pw to print the working directory, mkdir to make a new or empty directory, rmdir to remove an empty directory, cp copy files, cp, scp or ssh to do a secure copy from a remote machine or log into a remote machine, rm to remove files, mf to mv to move files or directories or rename them, find to find files or folders based on the name, data size, ownership or other parameters, tar to build an archive of files, and gzip and bzip2 to do compression. Permissions, to change ownership you use chown, to change group permission or to change the group you use change group, to change the modification you use change mod, to see the groups that you belong in use the command group, to see your ID use ID, to change the default group of your shell use the command new group. In terms of resource monitoring, you stop to see the most resource hungry processes, df to see how much space you have free or how much space is free on the disk, du to report the numbers and size of files on disk, free to show the available cached memory, job control, which displays the full path of the command, ps view active processes, control c kill the current job, control z suspend the current job, BG, put the suspended job in the background. FG, bring the suspended job in the foreground. Grep, search for substrings in a file or pipeline. Org or set is a pattern scanning and text processing tools. Sort is for sorting lines alphabetically or numerically. WC is for counting lines, words or characters. Cat is to print files or files to a standard output. More or less is for text viewing of programs. And head and tail is to view the start and the end of a file or a pipeline. Now piping and redirection. So the greater as sign after a command and means the redirection to a file, and the file is being overwritten. Two greater as signs after a command and pointing to a file would append to a current file, and lesser as sign is a redirection to as input to a command, and then the pipe symbol allows you to pipe the output from the one command to the input of the other command. Now, there's just a few things that you need to be aware of when working on Linux. On the Linux shell especially, that file and directory naming is case sensitive. Try to keep away from using strange characters in file names, and otherwise it needs to be escaped. Bash shell features, command and file name completion with the tab key. Browse through history with the up and down keys. Search for previous commands with the Control R combination key. There are also many ways to accomplish the same thing using various combinations of piping and together commands. In the shell, deleting a file is forever. However, in some of the desktop interfaces, when you work on the GUI, there is a recycle bin, but whenever you work on the shell, just be aware, if you delete a file, you won't be able to recover it. Then the last thing for this part 1 is that you would always be confronted with a situation where you would need to edit a file on a command line. So the best thing is to start learning a shell editor and its shortcut keys. So there's a few options available, such as Vim, Emacs, Nano and Pico. Nano is probably the easier editor to start with. Thank you, and see you for part 2.